Hi there, folks. Today we're looking at biconditionals and truth tables. So a biconditional statement, when we think about biconditional, it's basically two conditional statements wrapped up into the one. All right. And the two conditional statements that we're looking at are the original conditional statement and its converse. All right. And we signify that by using this statement of if and only if. All right. So if I say this thing, if and only if this other thing, it's basically saying that, hey, we've got the conditional statement and the converse all rolled into one. Mathematically, the way we express that is this. We have P and then this kind of double arrow and then the Q. All right. And if you think about conditional statements, the conditional was that single arrow going in one direction. It was if P then Q. But the biconditional is basically saying this. It's if P then Q, but also if Q then P. We can read it both ways. We can read it in each direction in terms of that. And that's why we use that double arrow to kind of express this thing. Okay? So again, when we see this, instead of being a typical if-then statement, we'll have something, if and only if this other thing. And what it means, all right, if that first thing is P and the second thing is Q, it's if P then Q, but also if Q then P. So I get the conditional and the converse, all right? For example, here's an example of a biconditional statement, all right? It says, a ray bisects an angle if and only if it divides an angle into two congruent angles. All right, so a ray bisects an angle if and only if it divides it into two congruent angles. And so what we want to do here is we want to split this up into the two conditional statements that it's telling us about. All right, and when you think about this, we still have like the P and the Q. Here's P and here's Q. Okay, so I still have those two pieces, but what this is saying is that I have two conditional statements. See, I could remove the if and only if and just write it like a conditional. If a ray bisects an angle, then it divides that angle into two congruent angles, okay? But because it's a biconditional, I can also do the converse. I can flip it. I can say if, all right, if an angle is divided into two congruent angles, then the ray bisects the angle. All right, so we can use those two statements. And the thing about biconditional statements, we only want to write biconditional statements when the biconditional statement is true, and we'll talk about that in a little bit. So here's a biconditional statement. Let's split it back up. It says if an angle, and I'm just going to use the angle symbol to abbreviate a little bit, then, and you can do the same thing. I won't care if you abbreviate. Okay, and so what I have here is if a ray bisects an angle, then it divides the angle into two congruent angles. All right, and yeah, I used the actual math symbols within the sentence just to save myself a little time. You can feel free to do that also. So there's the conditional statement. See, I just removed the if and only if. All right, and I write it as a conditional statement instead. But the if and only if signifies that we also have the converse, which means I can write this thing flipped around. Okay, so if an angle is divided into two congruent angles, again, abbreviating, then the ray the ray bisects the angle. Or you could say, then the ray is an angle bisector or something like that, okay? And so you can change the wording a little bit, and that's okay. But we want to state this as an if-then statement and then state it as the converse. That's what this thing means. And see, what's nice about this is instead of writing out, if this thing, then this thing, and then writing if this thing, then, and having to write both of those sentences, I can succinctly say that by just writing this one statement. This one statement covers all of this stuff. That's what a biconditional does, okay? For example, if I look at something like this guy, this time we want to write a biconditional, but notice it says write the conditional and converse. We won't actually write those. We'll just talk about them, all right? Then write a biconditional if possible. And we say if possible because we only want to write a biconditional statement if the biconditional statement is going to be true, all right? And it's only true if both the conditional and the converse are true. And so if you think back to the previous lesson when we were writing, the conditional statement and the converse and the inverse and the contrapositive, and then we went through and found the value, the truth value of each of those, okay? A lot of times what happens is sometimes some of them are true and some of them are false, all right? We can only write, or we only want to write the biconditional statement if those particular two pieces are going to be true. Okay, so let's think about the two statements here. So two angles are supplementary. Two angles have a sum of 180 degrees. So the conditional statement would be, if two angles are supplementary, then the two angles have a sum of 180 degrees. So before we move on, let's decide, is that true? If two angles are supplementary, do they have a sum of 180 degrees? And the answer is yes. Yeah, that was what supplementary angles meant. Okay, so the conditional statement is true. Now let's talk about the converse. All right, the converse, flip it around the other way. If two angles have a sum of 180 degrees, then the angles are supplementary. And once again, is that true or false? So if we think about it for a second, it's true. Okay, if two angles have a sum of 180 degrees, well, then they must be supplementary. That's the definition of supplementary angles. So the conditional statement was true, the converse was true, which means I can write a biconditional statement. So when I write the biconditional statements, I just literally write out these two statements with if and only if in between. Two angles are supplementary. And here's that statement, if and only if. And now I write the next statement. The two angles have a sum oh boy, my computer's starting to slow down already. 180 degrees. Okay? And so that's that biconditional statement. It's basically saying, hey, we've got the if-then statement and we have the converse and they're both true, so I can write it as one statement, all right, instead of writing it as two statements. Does that make sense? If I look at the next guy, again, same thing. Two angles are a linear pair. Two angles are adjacent. So let's think about the conditional statement. It would be, if two angles are a linear pair, then the two angles are adjacent. And so when you think about that for a second, that is a true statement. All right, remember, linear pair is basically when two angles are adjacent and form a line. So if it's a linear pair, then yeah, they're adjacent. It's part of what a linear pair is. So now let's think about the converse. Flip it around. If two angles are adjacent, then the two angles are a linear pair. So think about that for a second. If two angles are adjacent, does that automatically make them a linear pair? And the answer is no, that's false. Okay, angles can be adjacent and not form a line. All right, because that's what a linear pair is. Linear pairs, by definition, are adjacent and they form a line. But adjacent angles are just angles that are touching, not necessarily that they form a line. So the conditional statement would be true. The converse would be false. Therefore, this is not one that I would write a biconditional statement for. Okay? So this one, we would just say NA, not applicable. All right, we're not going to write a biconditional statement if the biconditional statement doesn't hold water, if it's not true. Okay? And you could write the biconditional statement, it would just be false. All right, so it's kind of a waste of our time. Let's talk about some of these other values. We've got the conjunction. All right, the conjunction is basically a statement connected with and. All right, a conjunctive statement is only true if both pieces are true. All right, so if each of the two statements is true, if one of them's false, the whole thing is false, okay? It's like if I said, I'm going to bring in, and I can't do this, but I'm not going to, I'm going to bring in cookies and ice cream. If I only show up with one of those things, I am a liar, all right? All right, the word and means I'm going to have both of those things, that each of those is going to be true, all right? Mathematically, here's the symbol for us. So we say P and Q. Yeah, so that little kind of upside down looking that little like triangle looking thing with no bottom. All right, so it's a little hat, little dunce cap. All right, that's the word, that's the symbol for and when we're talking about logic statements and truth tables and all that stuff. Okay, the disjunction, disjunction is basically an or statement. It's saying, hey, if this thing or this thing, and basically this is true if just one of the pieces is true. And go back to that example that I just gave. If someone said, if I claimed that I was going to bring in cookies or ice cream, and I only brought one in, well, I told the truth. I brought one or the other, okay? And if I brought both, I'd still be telling the truth because I still brought one of those things, okay? So an or statement is true if just one of the pieces is true, all right? And again, if you think back to algebra a little bit, you've seen some of this when you did compound inequalities, okay? Compound inequalities, remember, and we needed the overlap. We needed both pieces to kind of coincide for that to be true. But or we only needed one of the pieces, okay? And again, so here's the mathematical symbol for this. It's P or Q. We just flipped that thing upside down, okay? So it looks like a little V, all right? And what we're going to get into here is these things called logic statements, and we're going to define them as being true or false in certain situations, okay? For example, if I look at something like this guy, just talking about the truth value of this. So here I have three statements, all right? S is that the measure of angle A is 35 degrees, and I can look at the picture and kind of check that. J is that the measure is that angle A is acute, and T is that angle A is obtuse, okay? And so the first thing you want to do is kind of start thinking about the truth value of each of these statements, all right? Statement S is a true statement, all right? Because the measure of angle A, I can see it. It's right there. It is 35 degrees, all right? J is a true statement because angle A is an acute angle. But T is a false statement because that's not an obtuse angle, okay? So when you look at something like this, and again, if you want to start, thinking about these and say, all right, this one was true, this statement was true, and this statement was false. So if I look at that first one, it says S and J, all right? And remember, S was true, and J was also true. For an and statement to be true, both pieces have to be true. So S and J would have a value of true. And it has a value of true because both pieces are true, all right? If I look at the next one, remember S was a true statement, T was a false statement, but this is an or. And for or to be accurate, all right, for or to have a truth value that is true, just one of those pieces has to be true, all right? When you look at that angle, is that angle 35 degrees or obtuse? Yeah, it's 35 degrees, so yes, it's one of those things. And so here, the truth value here is true. The next one, T. Remember, T, the original T statement was false. J was true, but this says T and J. And remember, for an and statement to be true, both pieces have to be true, all right? Is that angle obtuse and acute? Well, no, that's impossible. So that's a false statement. Okay? And then this one, S and not T. So think about it this way. So S was a true statement. Remember, that negation symbol means the opposite. So the opposite of obtuse would be not obtuse. And when you look at that angle, is that angle not obtuse? Well, yeah. So the opposite of T would be a true statement. So now and, both pieces have to be true. And when I look at this, both pieces are true. Okay? So the whole thing is true. And then this guy, it says right here, we've got a true statement for S. The opposite of J would be false. Okay, so the negation of J, all right, not acute, all right. So that's a false statement, but this is an or. And remember, with or, only one of these pieces has to be true. So true or false gives us a reading of true. Okay, only one piece has to be true in order to make the whole thing true, all right? And both pieces have to be true, or only one piece has to be true. Let's talk about a truth table. A truth table is basically us running all the scenarios for the statement, all right? So basically, we don't have what S is. We don't have what T is. We don't have what R is. We don't know what each of these statements is going to be. All right. So I don't know if the statement is going to be true or false. So right now I just have R and S or not T. But I have no idea what those statements are. I don't know if R is true or false. I don't know if S is true or false. I don't know if T is true or false. So what I want to do is I want to make a table that gives me every scenario. Okay? And so here's what we do. The first thing we do is we kind of set this up using our values. So I've got a value of R, a value of S, and a value of T. Okay? Those are always the first thing I want to do is I want to define each of the statements. Yeah, I don't know what those statements are, and that's okay. And now I just run the scenarios. And the easy way to set this up is you kind of work backwards. Like if this guy was true or false, so basically like maybe it's true or maybe it's false. And see, I have to run all the scenarios. There's going to be quite a few. This one, true, true, false, false. True, true, false, false. Oh, I got to keep going. And I just happen to know this. It kind of cuts in half each time. That's why I started going backwards just to show it to you. Normally, I would start over here and go, okay, let me get 4 trues and 4 falses. Okay, so it's 4 trues, 4 falses. The next one, you go by 2s. True, true, false, false. True, true, false, false. And then the last one, you go by 1s. And if I had a 4th statement here, well, I could tack that on right over here. Maybe it was a Q. And guess what? Instead of having 4, I'd have 8 trues in a row and then 8 falses in a row. And then here, I'd have to extend this with 4 more trues and 4 more falses, okay? So it's always cutting it in half, all right? So if there's 4 values, you go by 8s and then 4s and the 2, all right? And here's the thing, don't worry too much about that setup. That's just kind of a memorization thing. You remember that that's the quick way to get all of your different scenarios, okay? And so when you look at this is all the scenarios, all of them being true. The first 2 true and the last one false. The first and last one true and the middle one false. The first one true and the 2 other ones false. And so it's kind of running every scenario of the different combinations of being true and false because we don't know if each of these statements is true or false yet. Okay? And then what we do here is we kind of follow order of operations. All right? And when you do this, you kind of think of order of operations the same way we always have, where parentheses go first, and then we would do like maybe a negation, and then we would do something like those ands and those ors, almost like they're addition and subtraction, okay, in terms of order of operations. So if I looked at this particular statement, so you see I have something in parentheses, it's the R and S, okay? And so basically, I'm going to run the scenarios for that and statement, okay? And so when we think about this right here, we're just looking at R and S. Right here, R is true, S is true. It's an and statement. They both have to be true, so that's true. In the next scenario, R is true and S is true, so an and statement would be true. The next one, R is true and S is false, so an and statement would be false because they're not both true. Okay, so I'm just running the scenarios here. True, false, that's false. Here, false, true, that's false. The next one, false, false, false. Okay, and again, I'm just looking right here at the S and T value, or the S and R values, to determine, hey, what values do I have here? I'm running the scenarios, okay? The next thing I would do is probably do the negation of T. All right, so now I'm going to do the negation of T. Ready? Remember, the negation of T is just the opposite of T. So let's see, here T was true in this scenario. See, I'm using this row. Here the scenario is that T is true, so the opposite of that is false. The next one, we had false, so now it's going to be true. And I can keep going. And again, I'm just looking at this column right here, and I'm doing the opposite for this column right here, okay? Because that's the piece that I'm looking at. That initial setup is just me running the scenarios of all the different T values I could have, and now I'm kind of mathematically changing them based on what's in this statement above, okay? And now I can run the whole statement, see? when you look at this guy right here, R and S, that's what I have in the parentheses. And then not T is what I have right here. So now when I run this scenario, I'm going to look at the two columns I just created to come up with this last guy. I'm going to say, okay, now I can run the whole statement. R and S or not T. And I go through and say, okay, I have R and S as a true, and I have not T as a false. So true or false, see, I'm just looking at the two columns I created in purple and blue. True or false, it's an or statement. Only one of them has to be true, so that's true. The next one, it says true or true. That's true. False or false is false. False or true is true. This one's false, true, false, true. And so basically what I've done is I've run every possible scenario, all right? And so if I find out all of a sudden, all right, let's say I fill in statements for each of these, and I found out that this guy is false, this guy is true, and this guy is true. I can immediately go to that row, right? So false, true, true is this row right here, and I can see the end result is false, okay? And so I've run every scenario. Now, once I know whether R, S, and T are true or false, I can jump right to the truth value of that statement, okay? I'm just running the scenarios. Let's do another one. Ready? So I've got my variables. I'm going to set them up. I've got P, I've got Q, and I've got R. And again, I'm just whipping through these, and I know that it's, going by fours. Let's see. True, 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 false, 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 false. That's the setup. Now by twos. And then by ones. And I don't think I would give you one any bigger than 3 values. Okay? So now I need to think about what the next thing I would do here is. So in order of operations, I would go inside parentheses first. And inside the parentheses, the first thing I would probably do is I would probably negate that Q. So let's do a column where I do the opposite of the Q values. Ready? See, instead of true, true, false, false, true, true, false, false, I go false, false, true, true. False, false, true, true. Okay? So I'm doing the opposite of that. Now, still inside the parentheses, I'm going to do this. I'm going to do the, let's go blue. If P, then not Q. And see, I have a column for P, and I have a column for not Q. So I'm basically, when I'm trying to figure this out, I'm looking at true and false here. So I'm looking at if true, then false. And that is a false statement. Okay? And with if-then statements, if you haven't realized it by now, the only time that they are false is if you start with true and end with false, okay? So if it's a Tuesday, then it's raining outside, okay? And if today was Tuesday and I look outside and it's raining, well, then that's a false, and it's not raining, then that's a false statement, okay? If I'm Mr. Jansen, then I am your math teacher, okay? That's a true statement, all right? Or if I am Mr. Jansen, then I am not your math teacher. That's a true-false, which is a false statement, okay? The next one is also true-false, which is false. The next one, true-true, which is true. True-true is true. Here's the tricky one, the false-false, okay? If an if-then statement starts with something that's false, okay? Like if my statement is, if unicorns exist, then I have magic powers. And here's the thing, you can't prove that to be false because unicorns don't exist. And maybe if unicorns did exist, I would have magic powers. You can't prove that that wouldn't be true, so we have to assume, or you can't prove that that would be false, so we have to assume that that would be true, okay? And I use a super ridiculous statement like that because there's no way to make that first piece true, all right? So you can't prove that I'm wrong, okay? So we assume that the overall value is true. Here's another false-false, which is true. If dragons were real, I would have one as a pet. You can't prove me wrong. The next one, same kind of thing. If unicorn exists, then my name is Mr. Jansen. See, it's false and then true. Well, it's still a true statement. All right? You can't prove, like, who's to say my name would change if unicorns existed? I don't know. And then this one's also true. That's probably the trickiest scenario for students because we don't like when the whole false somehow being true, okay? But if it's an if-then statement, all right, if this thing happened, hypothetical scenario, then this would happen. If you can't prove it to be false, we assume that it's true. And now I go to the last piece of this thing. If P, then not Q, and R. But again, I'm just looking at the two columns are created. It's an and statement between those two columns. So both pieces have to be true. So here we go. Ready? False, false, false. This one's false. Here's the true one. True and true. Next one, true and true is true. This one, false, false, true, true. And so now I've run every scenario. So I know once I figure out whether my statements are true or false, I can immediately find the end result of this statement by looking at this last column. Okay?